All right, iron coil being initiated from a copper coil, spinning a rotor. I know why it does this, I'm pretty sure, and I wanted to verify it. And I'm pretty sure it's doing exactly like I say. So, the way the material magnetizes from a inductor or from a magnet is opposite from the way it wants to induce the magnetism. So the magnetism fights against itself in an iron or a steel coil. So what we're expecting to see is we're just driving this one, okay? We're just inputting in this one to magnetize this. Then we're letting the rotor induct into the iron. So what we should see is the output go up as the speed increases and the input go down as the output goes up, exactly like we want. But the problem is, once this reaches a homeostasis where the induction is just as strong as the magnetism being injected into it, it will level off and continue at that speed. Okay, so that's what we're expecting to see. Let's get this in position and turn it on. Okay, this is our output. Our input, 1.63. As we're gaining speed, 160, 159. As we're gaining speed, 639, 707, 767. As we're gaining speed, input amperage is going down, and output amperage is going up. Remember, this is half. Divide this in half, this RPM, because it's hitting two magnets. As this is going up, as this RPM is increasing, output on the iron coil is going up, 29, 30. This is amperage. Is going up, and input is going down. Exactly like I theorized what's going to happen. Now, when this reaches proper speed, when it's up to speed, we should see that it levels off, where the input will stop going down and the output will stop going up and the RPM will stabilize when the magnetic field that's interfacing from the induction that it's inducing, when that magnetic field is equal to the magnetic field being sent through the material itself. When they balance, this phenomena should stop happening. So, .041, 216, still increasing. We're at 1.3 amps. 1.29 amps. As you see, it's starting to go 0.43, 1.28. That's still going down slightly. 0.44. This is still going up slightly, but they're starting to get closer to balance. I'm getting some vibration. This isn't anchored down, that coil. It's just kind of floating. 45, 1.26. Still going in the correct direction. But as you see, it's trying to go up. 46, 1.25. Speed is still increasing, but it's slowing the rate of increase. Now it's going by 1 RPM. The difference here, 124.046. So it starts to do what we want until the magnetic fields equal out. 0.047. So at this point we're getting to the limit. It might creep real slow at this point, 122.047, but it's not going to go much further than this. But it's good that we figured out which way the magnetism and the dynamics behind this are going. I'm going to stop the video here because this could probably go for a long time with very little change, if any more. Obviously the output sucks, but we're just looking for the data to show which way things are working with the configuration using an iron coil. All right.